Today, I want to talk about a very popular problem to put it on final exams in Calc 1. I give you the derivative, the graph of the derivative. And then ask questions about the function based on the information that you give in the derivative. Here's the style that I will present this problem, unless I give you like just line segments. Here's the way I do this curvy version of the problem. First of all, I tell you where these things happen. This clearly happens at 2. This must be happening at 5, and this is only 1 unit later at 6. This is not drawn to scale. But then I'll give you some information about this graph, specifically the area. So I give you the area so you don't have to approximate it, because some of you will look at this as a quarter of a circle, some of you will see a parabola, and some of you will just see a line like a triangle, and you'll all have these different values. And that makes it slow for me to grade. So what I'll do is I'll say this area down here, that area is 10. I'll say that area below from 0 to 2, that area is 10. And then I'll say the area from 2 to 5, I'll call that A2. I'll say that area, that looks like a lot more than this one. I'll call that 18. And then I'll say here, area 3 from 5 to 6. That looks like maybe it's a little bit less than that one. Let's call it 12. What I want to do is take some time to read what's going on with this graph. Now, in this case, I have just told you that this is the graph of the derivative of f. From here, we can talk about the f increasing and decreasing, and by how much. Now, if I want to know some values of f, I have to give you one value of the function from somewhere. I'll either tell you what's going on at 0, 2, 5, or 6 in this particular case. So if I want some values for the function, I will also, since this is the derivative, we're missing that plus c, right? This is the derivative. We took the derivative of some constant and got 0. So we got this shape, this derivative. This defines a family of functions. We don't know what the plus c is, so I have to tell you about the plus c. So if we think about the integral, we know that from 0 to 2, the function f decreases by 10, but I don't know where it started or where it finished. So I have to give you something about the plus c. So I either have to say f of 2 is equal to 40, or I will define the function with the second fundamental theorem of calculus. I'll just hand you a value, say f of 2 is equal to 40, or I will define the function with the second fundamental theorem of calculus. F of x is the integral from 2 to x of this function. If I use the second fundamental theorem of calculus, I'm also telling you that this is the derivative. So this is another way I could tell you that the graph is the derivative. So this does two things. Number one, it indicates that the graph you are looking at is in fact the derivative. This is the Calc 1 final coming up. It's a Calc 1 final being written by Professor Leach. Therefore, the graph that you're going to be looking at is the graph of the derivative, because that's the game that I like to play on final exams. This is also giving you a value. So either I just hand you a value, say f of 2 is 0, or in this case, f of 2 is 40. Or if I want to use a different value, and I want to tell you that this is the derivative without telling you that it's the derivative, I define the function using the second fundamental theorem of calculus. Say f of x is the integral from 2 to x of the given function. And that tells you two things. Number one, that the graph you're looking at is in fact a derivative of this f of x. And number two, I've told you what's equal to 0. Things that I can ask you, things that I can do with this information. Let's suppose that we pick this one. We want to think about what the derivative tells us. The sign of the derivative tells us the direction of the function. So the sign of the derivative will indicate whether the function is increasing or decreasing. The area will indicate how much increase or decrease we get. So one thing that I will definitely want you to find out that you know about functions and derivatives, I want you to know, I will ask a question where you can read the sign of the derivative, and that indicates the direction of the function. What we have here is that on the interval from 0 to 2, the derivative is negative, so the function is decreasing. So for this graph here, we see that f prime on the interval from 0 to 2 f prime is negative. So f is increasing, or sorry, decreasing. The derivative is negative, so the function is decreasing. In addition, the area tells us how much increase or decrease. So since we know the area from 0 to 2 is 10, we know that the function is decreasing and the function decreased by 10. So on the interval from 0 to 2, f decreased by 10. Just reading what's going on in the function. So if we quantify what's going on, if we happen to know that f of 2 is equal to 40, that's our given information. From 0 to 2, we see the derivative is negative, so we know that the function is decreasing. And the area is 10, so we know that the function decreased by 10. So there's area 1 telling us decreased by 10 on this interval. From there, we can go backwards and we can figure out what this value is here. On the interval from 2 to 6, we see that the derivative is positive, so our function is increasing. And we can see by how much. So on the interval from 2 to 6, the derivative is positive. So f is increasing. The interval from 2 to 5, we see the area is 18, so we'll see an increase of 18. And then from 5 to 6, the area is 12, so we'll see an increase of 12. So we can separate this out into 2 and see what's going on at 5. So the integral from 2 to 5 of f prime of x dx is 18. And the integral from 5 to 6 of f prime of x dx is equal to 12. So we're going to see from 2 to 5 an increase of 18. And then from 5 to 6, an increase of 12. The areas is telling us how much change we're seeing. So we had to know that one value. We had to know that f of 2 is equal to 40. Sign of the derivative tells you about the direction of the function. We also use the derivative to find things like local maximum, local minimum. And since we're on a closed interval, we can find global maximum, global minimum. So another thing that I will want to know about, if we're looking at a derivative, I want y'all to know that the derivative is how we find critical points, and we care about critical points because this will help us find local maximum and local minimum. So we're looking for a local max when we change from increasing to decreasing. We're looking for a local minimum when we change from decreasing to increasing. Since the sign of the derivative tells you about the direction of the function, if I want to find where the function changes from increasing to decreasing, I want to look for where the derivative changes from positive to negative. Then the other way around for a local minimum. There are a few ways that I could ask this information. I could ask for this information. Number one, I could just say, find any critical points of F and classify them as a local maximum, a local minimum, or neither. So the ways I could ask this question. I could just ask this as a critical point question. Here's the derivative, find me the critical points and classify them as a maximum, a minimum, or neither. Or I could say to find the maximum and minimum values of the function on this interval. When we're working with a graph, we're looking at a closed interval. So this is the most popular way I ask the question. I looked at a bunch of my old Calc 1 finals, and this is the way I usually default to. So find the maximum and minimum values. You want to find any local max and local min, and you also want to check your endpoints. So since I've given you a closed interval, the extreme value theorem says that there will be some maximum and some minimum value for a continuous function on a closed interval. So here you just need to find the local max and min and then check against the endpoint values because a global max or min can happen at endpoint of your closed interval. I'm just going to write it in words. So number one, find the critical points. Since f prime of 2 is equal to 0, f has a critical point at 2. Since f prime, there's a lot of ways to phrase this. So good news, there's a lot of ways you could explain this. Bad news, there's a lot of ways you could explain this. So you could explain this by saying, since f prime changes from negative to positive when x equals 2, or you could say, since f prime is negative before 2, and f prime is positive after f has a local minimum at x equals 2. 3 things happened in this. Number 1, we identified the critical point. Number 2, we classified it as a local minimum. Number 3, we justified why we classified it as a local minimum. Once we have our table of values, we can see that our local minimum is actually going to be the global minimum, the minimum value on this interval. And the maximum value happens at 6, because that's spent all that time increasing. When you're answering a question like this, I will typically remind you, but keep in mind, I will ask not just for the minimum and maximum values, you should indicate where those values happen. So not only what the values are, but where they happen. And as far as justification goes, if you just have a table of values with the correct values in it, that would suffice as justification. This would indicate to me that you read the problem correctly. You read these areas that I handed you as the changes in the function, and you identified which was the biggest number. How's everybody okay? Everybody looks so sad though. Is it because you're not looking forward to finals or you're not looking forward to Thanksgiving? See, it's really hard to read people right now because right now you're like, oh, finals are coming up. At least it's Thanksgiving weekend, so it's a short read. And some of you are like, oh, fuck, Thanksgiving is coming up. I have to get dressed up on a day off and go visit family. I don't know. I don't know what your situation is. I realize you might not be in a position where you can just like all say no to family, like a big family gathering. Any questions? Comment? It's not enough. And then some people are like, oh, that's right. Thanksgiving is this week. I think it all depends on what you have to bring. Sometimes if you're young enough, you can get away with not bringing anything. That's one of the benefits of being young and irresponsible. No one expects anything. So if you like actually show up with a pie or something like that, people will be like, oh, whoa, wait, what? But you want to be careful doing that because that might be expected moving forward. You know what I mean? Also, I don't know about the politics of your family, but a long time ago, if I showed up at my fiance's Italian family with my superior tiramisu, I would have been disinvited from like every other family gathering. Not that that didn't cross my mind, but the fact was, I made a better tiramisu. She's not going to watch these videos. This is my ex-fiance's mom. Although she might just sense it, come down here and murder me anyway. I'm not sure. I just don't even know. But mine went better. You know what I mean? I don't know if you want to pull that kind of power move on like a future in-law. All right. So the other thing that we can determine looking at the derivative, this is all just looking at direction of the function. The other thing we can do is look at the direction of the derivative and determine the concavity of the function. And this is also going to be a question about inflection points. So I can ask you questions about concavity, and I can ask you questions about inflection points. So tomorrow we'll look at this function, this graph again. So take a look at this graph again and think about the direction of this derivative, and that tells you about the concavity of the function and where the inflection point might be. It's harder to see because we're changing from, it's harder to see inflection points, but we're looking for maximum and minimum values of the derivative. So here's where our inflection point is going to be. All right, that's going to do it for today. I will see you all on tomorrow. Start studying for finals, start saving for retirement. Everybody have a good day, and thanks for playing.